Okay, so this is problem number 58 in Unit 5, where it has to determine if the pair of triangles are similar. And so we know how to prove if two triangles are similar, right? We got angle-angle similarity, we got side-side-side similarity, side-to-side, etc. So looking at this first one here, I don't know anything about the angles. So we're going to rely on matching up the sides to be proportional. So let's see, 18 is the longest side here, so that would have to match up with 12. 15 is the shortest side, so that would have to match up with 10. And then 17 match up with 11. If we do the proportions here, so we have 15 to 12, which is 1.5. Sorry, 15 to 10. I don't know why I wrote 12 there. 15 to 10, which is 1.5 or 3 halves. And we also have 18, that's what matches up with 12. That is also 1.5 or 3 halves. But unfortunately, when you match up 17 to 11, that's an oddball. That is not reduced to 3 halves or 1.5. So we have two sides that have the same proportion, but the third one does not. So therefore, I would say these two triangles are not similar. In the second example here, we have an angle of 110 matching up with an angle of 110. So let's see if the sides to either side of that angle create the same proportion. So we have 8 matching up with 5 and 8 matching up with 5. So I would say that beyond any doubt, 8/5 and 8/5 is indeed the same ratio. So yes, these two triangles are similar, right? We could kind of reflect this triangle over. K would match up with point H, and then we would have a similar triangle in terms of ratio of 8/5 or 8/5. So this one is similar. If we wanted to say or prove why, we would say side-on-side similarity. And then the last one here. So if we look at these tick marks, basically what it's telling us is that MNP is an equilateral triangle and SQR is an equilateral triangle. However, they are not equal to each other. Right? These all have one tick mark. These all have two tick marks. But no matter what value we plug in, like maybe these are all side lengths of 1, 1, 1, and these are all side lengths of 17, 17, 17. I mean, you can really pick any number, fraction, decimal, whatever. A rational number there, a positive rational number. It's still going to end up being the same ratio, right? Any side that you pick from this larger equilateral triangle matching up with the corresponding side in the smaller equilateral triangle, it's always going to give you the same ratio. So therefore, these triangles are similar by side-side similarity. Basically, this proves the point that if you have any two equilateral triangles in the world, they are going to be similar. Right? Every equilateral triangle is similar. If you don't believe me because of the sides, just think about the angles. Every angle in an equilateral triangle is 60 degrees. So if these angles are all 60, 60, 60, and these angles are all 60, 60, 60, they also have to be similar by angle-angle similarity. So whether you do it by angles or whether you do it by side, you're going to get the same result with that part. If you have any questions or comments, feel free to leave.